So it says, doctor travels to the east from city A to city B, which is 75 kilometers, the distance between the two cities. And that doctor travels, he makes that displacement, he makes it in 1 hour. What is the doctor's average velocity? So, first, what we need to do is take out the givens. It's given me 75 kilometers. Remember, the displacement involves direction. So it says the doctor travels to the east. So those 75 kilometers are to the east. And then the time is given in hours. Remember that I told you we need to do conversions. So if some displacements or some units are not given in the ones I told you from the beginning, you have to do a conversion. So it's going to be from kilometers to meters. Do the conversion and you will see that 75 kilometers is 75,000 meters. But displacement has direction, so you have to write that it goes to the east. Now the time is 1 hour. Now think about the time. 1 hour has 60 minutes and each minute has 60 seconds. So 60 times 60 is going to give you 3,600 seconds. That is the direct conversion factor that we always have. Both are correct. You can say data, you can say given, you can say known. It's okay. Call it the way you prefer. I don't have any issue on that. It's going to be fine if you say data. I always, well, I don't know, I like given. I don't know why I like given a little bit more. But data, I used to say data a lot. So yes, you can say both. So the problem asking you is asking you to find average velocity. So the average velocity is unknown, and you have here the equation. Average velocity is equal to displacement divided by the time interval. Displacement already in meters and the time interval in seconds. So when you perform that in your calculator, when you compute it, it's going to give you 20.83. And the units, as you know so far, the units, because you are dividing meters by second, is going to be meters per second. And you don't forget to write the direction, okay? So the doctor is traveling at an average velocity of 20.83 meters over second to the east. Now, you give it a try. Now, this one is for you. Okay, so get your calculator and practice. The peregrine falcon is the fastest of flying birds, and as a matter of fact, it is the fastest living creature. A falcon can fly 1.73 kilometers downward in 25 seconds. What is the average velocity in meters per second of a peregrine falcon? So, follow the procedure that you saw in the slide before. Okay, apply the formula. If you need to do a conversion, do it, and then tell me what is the answer that you got. And more importantly, tell me if the answer that you got is the same that you can see here in this slide. I got 69.2. What about you? What do you have to do with the kilometers?
Convert them to meters.
Convert it to meters. What do you have to do to the seconds?
Convert them to hours. Oh no, yes, landing.
It's already in seconds, okay? So then apply the formula. Did you get 69.2?
Yes.
So we're doing okay. Did you get a different answer?
There we can round it, Miss.
Well, I got 79.2 exactly, 79.
Yes, I got that, but I was asking you about that if you can
If you
round.
want, if you can leave it in 69 or in 70.
I don't know. I think it's better in 70. But if it's okay like that?
I mean, if you're having like a random conversation, you're not going to say, no, the Peregrine Falcon traveling 69.2. No, you're not going to say that. You're probably going to say, travels around 70 meters per second. But you are saying around, approximately, not exact. So yes, I mean, for verbal conversation, you can round it. Now, for my quizzes, no, don't round it. For my quizzes, don't round it. Okay. Now, remember this. Remember how to isolate. So the formula for average velocity is displacement per time. Okay, displacement, which is delta x or d, and the time interval that is just a t. If you want to isolate for the time, the formula that you have to use is displacement divided by the average velocity. If you want to isolate displacement, I mean, if the problem gives you the velocity and the time, the equation that you have to use to find displacement is the one that is here below that says average velocity times the time. Now, you have to notice the units must match. For example, if by some reason you tell me that this is 30 meters per second and you multiply it times the time of 1 hour, for example, it's going to be incorrect because here in the velocity you have seconds and in the time you have hours. So you need to do conversion. These hours must be converted to seconds. Every time that you have different units, you have to see if they match. So that's the isolation for average velocity in case that you need to find displacement or the time. This presentation must be written in your notebook. Okay, so respect the colors that are given here. Now, another thing to keep in mind is the equation for average, in this case, acceleration, which is change in velocity divided by the change in time. If you need to know the time, the equation is change in velocity divided by the average acceleration. If you want to know the velocity, the equation to use is average acceleration times change in time. Remember that this little triangle is called delta, and delta always represents a change, final minus initial, just like you did in the homework of average acceleration and velocity, okay? Final minus initial, always like that. Now, what happens for this exercise for average acceleration? Take a look. It says, don't forget to write down all these examples in your notebook. Don't forget. Now, let's see. Amazing. I didn't know I could do this. Probably you're gonna laugh if you watch this video. Probably not, just like around 7 students watch the video per day. So a shuttle bus slows down with an average acceleration of negative 1.8 meters per second squared. How long does it take the bus to slow from 9 meters per second to a complete stop? Okay, this example is very interesting. Take a look. It says, it says a shuttle bus slows down. So it means that the bus was traveling at a specific velocity and probably sees a cat and tries to slow down because doesn't want to crush the cat. So what happens? The acceleration is negative because it is slowing down. That's why we have a negative right here in the negative 1.8. It is slowing down, it's not accelerating positively, it's slowing down. So the change in velocity is negative. So in this case, the acceleration is going to be negative too. Now, when it says, how long does it take? When it says how long, it doesn't, it's asking you how long something is. No, how long does it take refers to time. So you have to interpret that kind of question as the problem is asking for the time. So how long does it take the bus to slow from 9 meters per second to a complete stop? So what happens in a complete stop? Is the shuttle bus moving or is still? What is a complete stop in terms of motion? Is it moving or not moving?
Not moving anymore.
It is not moving, right? If it's not moving, means that the velocity is zero. So when it says to a complete stop, it says from 9, it means that initially it was traveling with 9 meters per second and then finally stopped. Okay, so you have an initial and final condition for velocities right here. When it says from, consider from to be the initial condition of the problem, and 2 represents a final condition in the problem. So when it says from 9 meters per second, that is going to be our initial condition for velocity. And the final condition is a complete stop. So it's going to be 0 meters over second. That is huge, okay? I want you to analyze that and I want you to see where the data is coming from. Because from now on, physics is only going to be about word problems, gather information from the sentences. I mean, the problem can tell you from 9 meters per second to 0 meters per second, and that is amazing, that is perfect, that the book is telling you all that. But sometimes it's not going to be that obvious, okay? So you need to know how to gather that information from the word problem. Yes, Angie?
I have a question with the abbreviations that you make, like VI and VF. I wanna know the name to know them.
Okay, VI is initial velocity. Okay, so it is initial velocity. And VF is going to be the final condition for velocity. So maybe you want to write it down and or take a screenshot in this part of the video, because when I move on, I'm going to erase it. I'm going to erase like everything from there. So at least write the what is
And AAVG.
AAVG is average acceleration. Like this, okay? The only difference is that I use uppercase here because you couldn't see that the difference between one letter and the other, okay? So that's why I did it like that.
Okay, thanks.
Okay. So, question, in this problem, by taking a look at the data, Take a look. Average acceleration negative 1.8, initial velocity 9 meters per second, final velocity 0 meters per second because it says complete stop. And it's asking you about the time because it says how long does it take. Okay, so question, do we need to perform any conversion?
Square seconds.
Not really. You will see. Is that what here, when you apply the
Why
formula?
not?
No, because it's already in seconds. Take a look. Just okay. Here, take a look. Velocities, both are in meters per second. Okay, and the average acceleration is also in meters per second square. But in the end, when you divide this, the answer is, you have meters for length units and you have seconds for time units. So here you don't have to perform any conversion because you have everything in meters and everything in seconds, okay? But if for some reason you have kilometers per hour, then you have to convert to meters per second. If the time given is in minutes, convert to seconds. If it's in hours, convert to seconds. Here it won't be necessary because the units are matching, okay? Meters with meters and seconds with seconds squared. Even if it's square, it's just the seconds. The main unit is seconds. So how do you get this S for seconds right here? Let me, okay, I'm gonna try to do it like this. So when you subtract this with that, 0 minus 9 is going to give you negative 9 seconds, meters per second, sorry. Meters over seconds. And you are dividing by negative 1.8 meters per second squared. Okay, so negative with negative is going to give you a positive answer, positive 5. Okay, and now now the important thing is, I don't know if I told you before, I think I did, the sandwich method. The sandwich method. What you do here is you multiply those units that are in the outer layer and those that are in the inner layer. So you will have meters times the seconds to the second power divided by now
Seconds times meter.
meters times the seconds and seconds. So here the meters and meters are going to be canceled. And
oh yes, and you can cancel this one.
Yes, and you can cancel 1 second with one of the powers, and that's how you get the seconds. Now, it's a huge process just to get seconds, okay? I know it. But once you understand what with the units, it's going to be very simple. Or, like my students say, Miss, if you're looking for time, just write that we have the answer in seconds. That's it. That's how students make it. Now, I like to explain where the second comes from because I know that some people are very picky like me, okay? So I explain you where you get the things because I am that curious too, okay? So remember that second square is the same as having seconds times seconds. So you eliminate one of the seconds with the seconds below. And the remaining unit is just the second that you have over there. End of the story. Dividing fractions.
So every process is gonna finish in seconds.
If you're looking for time, yes. And remember this, time can never, ever be negative because you cannot go back in time. Okay, so if by some reason you get a negative time, no, terrible, that is terrible, okay? So negative time is not a good thing, never. So probably you did something wrong or you missed a symbol in any of the steps. So I suggest to do everything, okay? So will be 0 minus 9 is going to give you negative 9 in your calculator. Do it step by step. Don't worry, okay? And then divide by negative 5. The negative that is here. I'm going to get, okay. Amazing, amazing, amazing. So take a look. This key is the one that I use when I need to divide or something by a negative number. This represents a negative symbol. Not this. This represents subtraction. There are different symbols. There are different functions, okay? So it's going to be negative 9 divided by negative 1.8. 5 positive. Now, people say sometimes, Miss, but I got the same answer as you. Yeah, sometimes you'll get it, but sometimes you won't, and it's going to be incorrect because of that. Okay, so get used that this key right here, this one, represents negative symbols in the calculator. That's the one you use for plugging in negative symbols. Not this one. This one is subtraction. Okay. In any case, we continue. Did you get the same answer as me? Did you get the 5? Okie dokie.
Yes.
That's amazing. Now you give it a try. Find the acceleration of an amusement park ride that falls from rest to a speed of 28 meters per second in 3 seconds. Find the acceleration, okay? So from the equation for acceleration, you will put in the givens. Now, when it says from rest, take a look, it's in blue for a reason. From rest means that that attraction thing was still not moving, okay? And then during 3 seconds, it reached at a speed of 28. So it was still and then very fast falling down. So when it says from rest, it is a condition that means, because it says from, remember from represents an initial condition. And when it says from rest is 0 meters per second because it means that it wasn't moving, okay? So here, when it says from rest, it means that initial velocity is 0. Now, if it says to rest, to represents a final condition, and rest means 0 meters over second. So to rest is final velocity, 0. From rest is initial velocity, 0 meters per second. So notice the difference. The key is in the word problem, not in the formula. Okay. So did you copy the equation for acceleration? It's right here. Acceleration is velocity, change in velocity divided by change in time. So use this formula, okay, to get this answer. If you don't get it, let me know. So average acceleration. I always do it, you know. I always do it. I don't know why. I just like it.
Miss, excuse me. So, for example, in that part, the formula of acceleration is, velocity over time. So, but it's just in when you're calculating in slope in a graph, is that you write time, final time minus initial time.
No, it's the same equation. So it says average velocity Imagine this is a beautiful day. Okay, average acceleration, sorry, is equal to delta V divided by delta T. Okay, in the change of velocity, the final velocity is 2 at a speed of 28, so it is 28 meters over second, minus the initial velocity, because it says from rest is going to be minus 0 meters over second. Even though the answer is not going to change to the one that you have probably, it means something. Sometimes it's going to be incorrect, okay? So you better apply the formula the way it is. Delta T, or change in time, and the final time is 3 seconds, okay? And it's coming from rest. You assume that also the time of rest is 0 meters over second, 0 seconds, sorry, 0 seconds. So here, 28 minus 0 is going to give you 28, and 3 minus 0 is going to give you 3 meters per second divided by second. Did you get the same answer?
Yes, Miss. Thank you.
9.33, right? 9.33.
Yes.
And the second square comes from multiplying the seconds with seconds, okay? So 9.33 meters over second square. If you want me to explain you the seconds square, it is meters over second divided by seconds. And because you want to leave it as a fraction, you're gonna put an invisible one that actually is very visible. And you multiply the outer units and then the inner units. So you will get meters times 1 divided by seconds times seconds. So this will give you meters seconds to the second power. This is how you get the units that you see over there. It's not no, because Ms. Martinez said that there is meters per second. No, the units are there for a reason. That's the procedure I'm telling you for. Now, I know students say, no, if you're looking for acceleration, just write meters per second squared. It is true too, okay? People don't like to think too much, so they just write it. And it is okay only if you are always doing conversions. If you don't do conversions, the answer is going to be incorrect. So do conversions and be sure that acceleration will be meters per second squared. Do conversions and velocity is going to be meters per second. Do conversions and time is always going to be in seconds. Like that. If you don't do conversion, then time can be in any unit that people write it. I don't know if I have the time for this one. I feel like the cat that is over there. I'm like, do I fish it? I'm like that. But let's see. They're missing 4 minutes. No, I'm not going to have the time. So we're gonna leave it like that because this exercise requires a little bit more explanation than the others that we did, okay? So we're gonna leave it here. I'm going to send you the presentation. Remember that we are here in the exercise about the amusement park, okay? So we're gonna leave it here.